Hello everybody, my name is Jonathan Tipo and today we are going to go over practice problems for calorimetry. Alright, let's get started. So how much energy do I need to heat up 16 grams of water by 29 degrees Celsius? Okay, so first off, let's write down what we know. We're looking for energy and we have 16 grams of water, which is our mass. And we also know water has a specific heat capacity of 4.184. So we know our 4.184 is equal to specific heat capacity, and 29 grams or 29 Celsius is our delta T, change in temperature. Okay, cool. So we got J, which is also known as Q, and we got our MSAT equation. So Q equals MSAT. So what we can do is just plug everything in. So we know we got 16 times 4.184 times, and then delta T, which is 29 Q. And when you multiply that out together, you should be getting 1941.38 joules. All right, makes sense? All right, moving on. So a hot rod or hot iron rod of 200 degrees Celsius. So we know temperature initial of iron rod, I'll do IR, is 200 degrees Celsius. We also know the mass of the IR is 130 grams, is dipped into 60 ml of 15 degrees water. Okay, so we also know that for water specifically, well, we know a couple things. Water, our specific heat is 4.184. 15 degrees Celsius is our temperature initial, and 60 ml, remember that 1 ml is equal to 1 gram. So let's transfer this all together. We have the mass of water is equal to 60 grams. Got our temperature initial of water is equal to 15. And then we've got our specific heat of water, again, is 4.184. So if the specific heat capacity of the rod, so we got also specific heat capacity of IR, is 0.45, what is the final temperature? So temperature final, we don't know. So one thing that I would like to note is because this is a system surroundings and it looks like it's a system surroundings equation because we have two different calculations that were given and two different heat capacity, we can set up, remember that system surroundings is QA is equal to negative QB, and we can just replace QA of MS delta T is equal to negative MSAT, right? And remember our system looks like it's going to be the iron rod, and then our surroundings is equal to the water, right? Because we're dipping the iron rod into water. And then to kind of visualize that, here's the water, and here's the iron rod. And this way you can easily see which one's the system, which one's the surroundings. Right, it's the water surroundings because it is literally surrounding our iron rod. Okay, cool. So because this is a system surroundings equations, the temperature final of the IR is also going to be equal to the temperature final of the water, right? Because this is an equilibrium and it basically equalizes the energy between the system and surroundings. This is what this equation tells us. All right, so from here we can start by rewriting this equation. So MSAT is equal to temperature final minus initial, and then negative M water is equal to temperature final minus initial. And from here, we can start inputting things. So remember, this is the iron rod. So iron rod, mass of the iron rod is 130. Specific heat is 0.45. And then we also know, well, we don't know the temperature final, but we know it started at 200 degrees Celsius. All right, so let me just move this real quick. I'll move this down here. Okay, so this is your iron rod. And that is equal to negative MSAT. Let's use red. So negative mass of water is 60 times the S, specific heat of water is 4.184, times temperature final. We don't know, but we know it starts at 15 degrees Celsius. So from here, what we need to do is we need to isolate the TF, or the temperature final, and by doing that, we need to distribute and then isolate. So this is just algebra at this point. Remember that if we are going to do this, we are going to be looking at multiplying these together and then distributing. So it's going to look something like 58.5 times T temperature final minus 200 is equal to negative 251.04 times temperature final minus 15. Right, and then from here, what can we do? We can distribute this. So in this chapter, in this section, having very good algebra skills is highly important, right? So if you're not very good, either rewatch this video again, or just keep practicing. Okay, so when we eventually get that, we distribute that, and we are left with this. Minus, and then 2 minus signs is equal to a positive. It's 3765.6, right? And what I just did is I just multiplied this by the inside terms. Okay, so I feel like I can erase this now. Okay, so now what we can do is we are looking to isolate our TF variables, and that just means putting them both on one side. So 25.024 TF, we do it by the inverse, and we add it right here, 251.04. And then we can also move this other side to this side by adding 11,700. So plus 11,700. And we are left with something that looks like 309.54 temperature final is equal to 14965.6. And last thing we need to do is just isolate the TF by dividing everything by 309.54. 309.54. So all of this cancels out, and we are left with TF, our temperature final, is equal to 49.96 degrees Celsius, right? So what is this saying? This is saying that if I take this hot iron rod and dip it into this cold water, the temperature will drop or rise, depending on what you're talking about, to 49.96 degrees Celsius. So that's just the temperature final, and remember this is an equilibrium, so the water and the rod are at the same temperature. Okay, cool, last problem, and then we'll call it a day. So heat capacity of a block that starts at 5 degrees Celsius, all right, so we're given temperature initial, and then 18 degrees Celsius, so that's temperature final, and then we have Q of 103 joules of heat. Okay, and we're looking for heat capacity. So remember that heat capacity is C, and it's not the same as specific heat capacity. It's specific heat capacity is S, heat capacity is just C. And we're looking for C, sorry. So we'll keep this as variable C. And what is our only equation that uses heat capacity? What's the QCat equation? And let's break this down even further. Q is equal to C times temperature final minus temperature initial. All right, and all we just need to do is input. So that's 103 is equal to C times temperature final, which is 18, minus 5, which is temperature initial. All I would just need to do is divide this by 18 minus 5, divide both sides by 18 minus 5, and then we are looking at 103 divided by 13 is equal to C 13 over 13, right? I just multiplied, or I just solved that one. 18 minus 5 is 13. So we are looking at C is equal to 7.92. And what are our units? Well, C is equal to 7.92 joules per degree Celsius. Right, and remember, heat capacity is not the same thing as Celsius. Just remember that. These two are not the same. Okay, well that goes all the practice problems with calorimetry. If you have any more questions, just review this video, and I will see you in the next one.